Hello and welcome again. Today we're going to implement a prediction model for churning customers in telco industry. This time we're going to utilize RandomForestClassifier. The last time we have implemented logistic regression model, I believe random forest classification also is a strong method for binary classifications, as we're going to implement it for churning customers. Yeah, let's import, like we have already imported all the libraries we need, but we're gonna call our CSV folder file read underscore CSV r. Yeah, it's all good, and as always df.head, it's going to get us to see first 5 rows here. The first thing I realized, there is so many object values formats here. There's string formats like gender, customer ID, which is seemingly unique. There is also payment methods, contracts, so maybe we can see the types of all these column CAD types. And yeah, there's a lot of objects here. There's also, I realized that there's total charges also in an object format, so it needs to be turned into a numeric value, as we always assume it's a numeric and it's here numbers. We can see that. So the next thing, maybe we can go ahead and print out all the null values. Df is null and sum. There's no null values. It's a good starting point here. We can also maybe visualize it in a Seaborn library, sns.heatmap, just to be able to see it. Then fancy result is null, and can put that here, c bar equals to false. Also cmap for the visualization, type viridis, and y-tick labels is false, and plt dot show, maybe I can also put that in here, a title, plt dot title, missing value map. See, there is no missing value, just a fancy format in a plot. So next thing, as I said, there's total charges up here. Let me get that column's name, just not to make any typo. Df total charges equals to pd dot to underscore numeric, and again df total charges, and errors equals to errors. Yeah, and then we can see that the types, yeah, it's now float, it's in numeric format. We converted the total charges to numeric and set errors to course to handle non-numeric values by setting them to NA. And then very next thing, I want to see the distribution of total charges. Also there is another thing, and again a Seaborn library sns dot, I need histogram this time to see them distributed over the charging amount, total charges, and then KD equals to true, and bins I want to set as 30, and I also want to go ahead and select the figure size. What I want is to be 8 to 5, and now we can also assign a title for our histogram graph here. Distribution of total charges, and then one last thing is always plt.show. Yeah, we can clearly see that the total charges from the amount $20 up to over $8,000, there is a distribution here. We can also, I want to see monthly charges. I think that should better show us, we can clearly demonstrate how much amount monthly charges more inclined to churn the customers. So SNS dot, this time I'll use box plot. X is gonna be churn column here, and Y monthly charges, and then of course the data is data frame, and this time the title is gonna be monthly charges by churn status. plt.show. Yeah, we can clearly see that above $60 range, around $80, the mean customers started the churn. 50% of them around accumulated on $80, but $60 I think maybe a really significant amount for many of customers, and I would like them to churn. That's a good point. And next thing, we can see all the correlations on a heat map. So let's go ahead and do that. So core equals to, again, df.core and numeric on true, and what we want to do is to again utilize SNS Seaborn library, core here, annotation true, and CMap. Again, I really like coolworm, and cbar also true. And let's go directly to show the columns here. Maybe I am missing a few things here, I'm not sure, it's not showing all of these, so maybe can also implement one more thing here if it's correct. Dot to f, hope that works. It works, but it's not that I expected. We can see here the total charges, aligning with monthly charges. This is pretty much expected, and total charges with tenure is highly correlated here. Also monthly charges a little bit correlated. This is pretty much what we assumed. And next thing, we can go ahead with the future engineering. So label encoding here. Future engineering. And with the label encoding, we will need to encode categorical variables. So we want to do first assign categorical columns into categorical underscore columns in df.select underscore dtypes. Dtypes is going to look for objects, of course, include equals to object dot columns. Hope this works. And data object should be object. Dtypes object, yes. Yeah, there you go, no errors at all. So we can go, I want to assign a lead to label encoder, and then for each column, categorical columns, if column of course is not customer ID, since it is a unique value, it's not we cannot use it as a future. Here df column is equal to label encoder dot fit underscore transform and df column, and let's run this. It should work. There you go. So we got all these columns label encoded and all of them into transformed into numeric value. And next thing, we can split the data into X and Y. We can get rid of and avoid customer ID again in the next point, and then separate churn and all the other data set to be able to train and test. So let's call it train and test. Here we will need to split X and Y. Here df.drop. Again, what we need to drop is of course churn, which is our target value, but also customer ID, which is the unique value here. Shouldn't be in our model, and of course in the axis one, and then Y of course is going to be churn. Yeah, it works quite well. So X underscore train X underscore test, and also for Y equals to train underscore test underscore split scikit-learn's gradient test size is gonna be equal to, I'm gonna go ahead with the 20% this time, and random state as always 42, and I think that's all done for this one. For random forest classifier, we will need to also have another step for this. RFC underscore model equals to random forest classifier, and estimators, I'll go with hundreds, and random underscore state equals to 42, and yeah, it works. And one last thing, rf underscore model dot fit is going to be X underscore train and y underscore train. RFC model. RFC model. Yeah, random forest classifier. Yeah, that's all good. Now we're now able to see the predictions, how well we perform. So RFC underscore model dot predict is gonna be x underscore test, and we will need to evaluate the matrix here. So we'll assign accuracy, that will be precision, there will be recall and F1. So let's go one by one. Accuracy underscore score, y underscore test, and predictions. And next thing, precision underscore score is again y underscore test predictions, and post underscore label equals to 1, and then recall score y test predictions post label 1 F1 score F1 underscore score y test predictions, and post label 1. Then we're gonna print them out. F accuracy is gonna be accuracy, since we assigned them in here. Let me type that in here. Precision, recall, and F1 score. So it's a little weird. I believe there is it shouldn't be the same. Precision, y test, predictions, post label, recall score, recall equals to recall score, accuracy score. Yeah, of course. Made a typo here. Recall, and then also F1. Accuracy is quite nice. It's around 80%, but precision 65. Not performed quite well. Recall and F1 score. Overall harmonic overview of precision and recall 55%, not quite good. Accuracy is quite nice, so maybe we can go ahead with this one this time, but I believe this model needs some hyperparameter tuning, so we can go ahead next time with this one. But I believe accuracy is quite nice. F1 score not performed quite well. This time I have applied random forest classifier to be able to predict the customer churn for telco industry. Thanks for watching me.